Assalamualaikum. Okay, now we come to the summary of the chapter 4, Force System Resultant. Okay, the first thing is about the moment. Okay, what is the moment? So we define the moment is tendency. Okay, a force to cause a rotation to the system. Okay, the numerator we can define as m equal to f times d, where d is the perpendicular distance or shortest distance between the first line and the rotation point of point 0. Okay, so if you see here that the d is perpendicular or the shortest distance, okay, along the first line. So you need to understand why the first line, okay, because the f is sliding force, okay, and the direction we use is as a right hand rule, where the thumb is showing the direction of positive of the axis direction, and we use the clockwise or counterclockwise. So normally we assume the counterclockwise as positive and clockwise as negative. And the total of moment, okay, we need to define the summation of the whole forces, okay, that create the moment, okay. So we need to calculate each one of the forces that develop the moment. So it's a summation of the moment from each forces. Next thing is about the moment in vector formulation, okay, how to calculate the moment in vector. So normally we use the vector formulation for 3D problems, okay, and for the 2D problem, normally we use the scalar formula. Okay, for vector formulation is equal, the moment m is equal to r cross product f, where is defined as the determinant of I, J, K, the component of I, component J and K, and with the magnitude of Rs, Ry, Rz, and magnitude of Fx, Fy, Fz. Then you need to understand how the operation of this formula. Okay. But another thing you must understand, the R is position vector from rotation point or point 0 to any point on the first line, and the F, okay, is the sliding force that can slide along the first line. Okay, so you need to select any point of on the sliding on the first line that can become the position vector. Okay, and if you have more than one forces, you need to add up, okay, all the forces, okay, the cross product of the R I cross product Fi. So then we need to sum up all the cross product to get the total moment at a point or point 0. Okay. Next is about the moment about a specified axis. Alright. Okay. If you want to find the moment, okay, along an axis, okay, along an axis, we can define by scalar, okay, m is equal f times d, where f is a force and d axis is the perpendicular distance between the axis line and the first line. So to be simplified, we need to understand that the rotation axis, the direction of force or the first line, and the distance, three of these must be perpendicular on each other. Okay, so then we can define, okay, the moment, okay, about a specific axis. Okay, again I said that the rotation axis, the direction or the first line, and the distance must be perpendicular on each other. Okay, so we can view this system in 3 dimensions. Okay, so this is about the scalar, by using the scalar. Okay, but by using the vector, we can define, okay, first the vector by using the definition of its magnitude of the moment around the axis as ma equal ua dot product in bracket r cross product f, where ua is the unit vector of the axis. Okay, unit vector showing the direction. Okay, so you need to understand what is the unit vector. So it is the unit vector for the axis a, and dot product with the r cross product f, where r is the position vector that locate the distance between the axis and the first line. Okay, so r we can take the distance between any point on the axis and any point on the force line. And F, of course, is the force vector where we can decide, okay, this product as the determinant of the magnitude of unit vector and the magnitude of the position vector and the magnitude of the force vector as shown, okay, here of the determinant operation. And then we can get the MA, which is the magnitude. To get the vector for this moment MA, we need to dot product the magnitude of MA dot product with the vector UA. Okay, so we can get the vector of the moment at the specified axis. So UA is the vector for the specified axis. R is position vector between any point on the axis, any point in the force line, and F is the force vector. Okay, next is couple moment. Okay, by scalar we define the couple moment M is equal F times D, where D is the perpendicular distance between these two force lines. Okay, where the force we must understand must be parallel, and the force had the same magnitude but have opposite direction. Okay, so the condition of the couple moment. All right. So we can define it as F equal M equal Fd, and by vector we can calculate the couple moment M equal to R cross product F, where is R is the position vector between any 2 points on each force lines. Okay, so for the vectors, so we can select any 2 points along the lines. Okay, so F, of course, is one of the force vector. Okay, no need to add up with the force. Just select one of the force vector. Okay, this is couple moment. Okay, next, okay, is equivalent system and the resultant system. Okay, this is how we convert, okay, the multiple loading system to be a single loading system. Okay, or we simplify, okay, multiple loadings to become a single loading. So the first step we need to do is to calculate the force summation. We add all the forces, okay, become a single force, and then the second step we calculate the total of the moment, okay, around a point, okay, for example point 0, okay, or point A, any point that we are required to find. Okay, however, when we calculate the moment summation, okay, the moment summation is depend on the loading action point. So we can determine what is the single loading point. Where is the single loading point, whether it's point O or other point. Okay, so the amount of the moment might be different depend on the loading point. Okay, so we need to understand and need to be careful. Okay, okay. So what we had learned in the chapter 4 as conclusion, okay, we had learned how to determine moment and simplify multiple loading system to be a single loading system. Okay, these two main things in this chapter is how we determine and analyze action loading in the system that we're going to apply in the next chapter. So what we do in this chapter is determining or analyzing the action loading, okay, on the system or on an object. Okay, so when we know the action loading on the system, then we are going to apply in the next chapter, right? That we are going to learn the reaction loading. Okay, when we understand the action loading and the reaction loading, then we can develop the equivalent condition for the system and do analysis for the system. Okay, that's all for this chapter. Okay, please do the practice and good luck. Thank you.